factor. If it were higher degree, for instance, if I had a t cubed plus t minus 2, or which would still have given me a 0, I would take the t minus 1, and using long division of polynomials, I would simply divide it in to the numerator polynomial to find the other factor. Likewise for the denominator. In other words, this becomes a straightforward process. All right, now let's look at another problem where we have a limit of the form 0 over 0, and our numerator and denominator are both polynomials again. This time we'll have to deal with higher degrees, though. Okay, so here I have the limit as x approaches -2 of -2x minus 4 divided by the quantity x cubed plus twice the quantity x squared. Well, again, if we try to use the limit laws in the simplest form, we would just substitute -2 for x everywhere. But if I do that, I've got a 0 in the denominator. Notice -2 cubed is -8, whereas -2 squared is 4 times 2 is now a plus 8. We'd have -8 plus 8 is 0 in the denominator. Well, what about for the numerator? -2 times -2 is plus 4, minus 4 is 0. So again, we have a limit of the form 0 over 0. Of course, that tells us that x minus the -2, which in this case means simply x plus 2, must be a factor of each of these polynomials. Well, in this case, the factorization of the denominator is actually easy because notice we've got x cubed, x squared. We see instantly x squared is a common factor, so we pull that out. We have x squared times the quantity x plus 2. And in the numerator, let's factor out our -2. We have -2 times the quantity x plus 2. And so that's what we want to take the limit of as x approaches -2. So far, all I've done is an algebraic rearrangement, but next what I'm going to do is cancel the x plus 2's, the common factors. And so finally then, by algebraic rearrangement, we've simplified our limit to just being the limit as x approaches -2 of the quantity -2, this is over x squared. So at this point, try again. Replace the x by -2. We get -2 over -2 squared, which is -2 over 4, or finally just -1/2 as our limit. So what happened here? We had a limit of the form 0 over 0. We're taking the limit as x approaches -2, so x minus -2, which is x plus 2, has to be a factor of the numerator polynomial, has to be a factor of the denominator polynomial. In this case, we had a third degree polynomial in the denominator, so the factorization could be a bit difficult, but in this case, fortunately, it was easy. We just factor out an x squared. However, if this denominator polynomial had been longer and there wasn't a simple common factor to pull out, I would have taken x plus 2 using long division of polynomials divided into that polynomial, and that would give me the other factor. In other words, that's just a straightforward procedure. Okay, let's look at another problem where we have to deal with the limit of the form 0 over 0. In this case, we're going to be dealing with the radical expression. So here we have the limit as x approaches 1 of the quantity x minus 1 divided by the quantity square root of x plus 3 minus 2. Now, if I replace the x everywhere by 1, the numerator is 1 minus 1, which is 0. And down here in the denominator, 1 plus 3 is 4, square root 4 is 2, and 2 minus 2 is 0. So again, we have a limit of the form 0 over 0, and here we see this difference of a radical and a number, which we could in other situations have a difference of two radicals. But do you remember how to deal with that? Why don't you try this one on your own and then see how I work it? Okay, so here we have this problem. We've got 0 over 0 and a difference of a radical with a number. And the way we deal with that is we multiply by top and bottom the expression we get by replacing this negative sign with a plus sign. In other words, copy the thing down, the two terms, but replace the negative sign by a plus sign and put it in both the numerator and denominator. So in effect, what we have here is just a big complicated expression for the number 1. Well, when I multiply the difference of the two terms by the sum of the same two terms, notice what happens. Radical times radical, that's just going to be x plus 3. The negative 2 times the plus 2 is negative 4. And what about the cross term? Negative 2 times the radical plus 2 times the radical. They cancel out, so the radical's completely gone, and our denominator is simplified down to x plus 3 minus 4. What about the new numerator? Well, that's simply x minus 1 quantity times the quantity radical, x plus 3 plus 2, all of that. So that looks still a little complicated, and we have to take the limit as x approaches 1. But notice what happens when we simplify the denominator. X plus 3 minus 4, well, that's simply x minus 1. So we have the limit as x approaches 1 of the quantity x minus 1 times radical x plus 3 plus 2, all divided by x minus 1. And so at this point, we see the x minus 1's cancel. And so our final problem has reduced to limit as x approaches 1 of radical x plus 3 plus 2. At this point now, the limit rule tells us that's a power, 1/2 power, sum of terms, limit of constant is a constant. Again, just replace the x by 1. Nothing can go wrong now. We have square root of 1 plus 3 plus 2, which is square root 4 plus 2, 2 plus 2, that's 4. And so there's the final answer, the number 4. Again, remember this trick. When you see a radical minus a number causing you a problem that's producing a 0, making 0 over 0, or if you see radical minus another radical, both square root radicals, then simply multiply top and bottom by the sum of those two terms. Well, now we've seen how the limit laws apply to evaluate limits of complicated algebraic expressions. So remember, the first step that the limit laws in effect give us is that if you replace the variable by the limiting numerical value, and if everything makes sense, then that's going to be the limit. But if something goes wrong, for instance, you get a problem with a radical or zeros in denominators, then that's telling you the limit laws have broken down, and then you have to do some cancellation and algebraic rearrangement in order to get around it. Again, what you want to do then is rearrange so that the limit laws do apply. Now remember, there are two basic things to keep in mind which will be getting you through most of the examples. The first thing to keep in mind is that if you have a limit of the form 0 over 0, where the numerator and denominator are both polynomials, then that's telling you how to factor those polynomials to cancel the common factor that's causing the 0. if you have radicals in the denominator, a difference of two radicals or a radical minus a number, and these are square root radicals, the way to solve the problem is to multiply top and bottom by the sum of those same two terms to get rid of the problem. Well, now that you've seen some of these examples work, you might want to try some on your own.